Here we have a table of data with x values, values at different functions for f of x, its derivative, values for g of x and its derivative. Here we go. The functions f and g have continuous second derivatives. The table above gives values of the functions and their derivatives at selected values of x. A. Let k of x equal f of g of x. Ooh, we have a composite function there. Write an equation for the line tangent to the graph of k at x equals 3. In A, we're looking for the equation of a tangent line. Classic problem. Remember, you always need to find a point on the line and the slope of that line. So let's find the point first. We know the x value is 3. I'm going to find k of 3 since I'm looking for the line that's tangent to k. So let's see. That's going to be f of g of 3. So let's look at our chart here. G of 3 is 6, and f of 6 is 4. So this whole shebang equals 4. So we have our point. Now let's find our slope. Slope of the line will be the slope of k at that point. In other words, the derivative of k. So I need to take the derivative of k of x. We have a composition of functions. So I need to do the chain rule. This is the classic form of the chain rule. The derivative of the outside times the derivative of the inside. So now I'm going to put 3 in and find the slope at the point where x is 3. All right, so here I go. Again, I'm using this chart. So g of 3 here. This g of 3, look at my chart, is 6. F prime of 6 is 5 times g prime of 3, I'm just looking on my little table, is 2. So my slope is 10. Da, 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 da. So I'm ready to roll. So my tangent line equation, I'm just going to do point slope, is y minus the y value equals my slope times x minus my x value. There's my answer. You can leave it like that. Point slope form is a beautiful form. There's the equation of my tangent line. B, let h of x equal g of x divided by f of x. A quotient. Find h prime of 1. For B, we're looking for h prime of 1. I've got a quotient. I have to take the derivative. Quotient rule. Again, just these classic rules. The derivative of the top times the bottom as it is, minus the top as it is, times the derivative of the bottom, all over the bottom, quantity squared. Not bad. Now all we have to do is substitute in a 1 for all of these. Okay? I'm just going to do this. Boom, boom, boom. Looking at my table, g prime of 1 is 8 times f of 1, negative 6, minus g of 1 is 2, times f prime of 1 is 3, over f of 1, which is negative 6, quantity squared. And there it is. That wasn't bad at all. And your answer is negative 54 over 36. You certainly could write that as -3/2 if you wanted, or -1.5, but you do not need to simplify. And C, evaluate the integral from 1 to 3 of f double prime of 2x dx. All right, well, the antiderivative of f double prime is going to be f prime of 2x, right? And we have to compensate for the chain rule. If I were to take the derivative of this, the derivative of f prime of 2x would be f double prime of 2x times 2, right? So I have to compensate for that times 2 and put a 1/2 out front. And this is from 1 to 3. Gosh, that wasn't as bad as we thought, maybe. So this is going to be 1/2 f prime of 2 times 3, or 6, minus 1/2 of f prime of 2 times 1, or 2. Again, table. F prime of 6 is 5. F prime of 2 is -2. And there's our answer. Five halves plus 1. You could leave it like that, or you could write 7 halves. But you can leave things unsimplified. That's not a problem at all. And there you have it.